this is going to be a video all about how we would do dilations on a shape. So our goal by the end of this is to be able to dilate a shape if we're given something called a center of dilation and a scale factor. So we need those two things in order to do a dilation. So what a dilation is just what it sounds like. You know, if you go to the doctor and the eye doctor and they dilate your eyes, they make your pupils bigger, right? But it doesn't change the shape of your pupil. So what we're doing with a dilation is making a shape bigger or smaller. It goes both ways. Given a scale factor and a center of dilation. So a scale factor, if you might remember from concept 15, we talked a little bit about those. That tells us how much bigger or smaller something is. And then that center of dilation is where it's where you're counting from, kind of like where what point you're dilating around. So it gives it location in space is what it ends up doing. Okay, so just for kind of what we're going to end up using them for, the scale factor is going to be something that we multiply by, and a center of dilation is the point that we're going to be counting from when we actually do the physical dilation. Okay, so for those of you who like steps, we've got 5 steps of doing a dilation here. So we're just going to go through this example following these steps. So your first step is going to be to find the center of dilation and mark it. So we're going to put a point there. So for this first example, it tells us our scale factor is 2, and the center of dilation is the origin, which is the point 0, 0. So I'm going to find the point 0, 0 on my graph right here and mark it. That's where we're going to be starting from for all of these steps. So step 2, count from the center of dilation the directions to get to one of your points. So I'm going to start with this point right here. And I'm going to count what my instructions are to get from here to here. So to get there, I would have to go to the right. 1, 2, 3. So I'm going to write that down. Right 3. And then I have to go up 2. So I have to go right 3 and up 2 to get there. Then, step 3 is to multiply the directions by the scale factor. So now my new instructions, so my dilated instructions, are going to be multiplying it by 2. So instead of right 3, I'm going to go right 6. Instead of up 2, I'm going to go up 4. So from the origin, now again, because we always start at our center of dilation, I'm going to go right 1, 2, 3, 4, 5, 6, and up 1, 2, 3, 4. And that's where my new point is. So instead of this point, it's going to be over here. Okay, so now I'm going to do that with the rest of my points. I'm going to follow that exact same process. So I'm going to go repeat it for all the other points in the shape. So let's do this one next. To get to this point, I have to go right 1 and up 1, 2, 3, 4, 5. Okay, so instead of right 1 and up 5, my new instructions will be right 2 and up 10. So right 1, 2, up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And there's my new point for that one. Alright, following the same process for my next point. We have to go left this time. 1, 2, 3, 4. And up. 1, 2, 3, 4, 5. So instead of left 4 and up 5, I'm multiplying by my scale factor of 2, so left 8 and up 10. So left 1, 2, 3, 4, 5, 6, 7, 8. Up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Alright. For my next point, we just have to go left 4. That's all. We don't have to go up or down. So then instead of going left 4, I'll just go left 8. Then for my last point, I don't have to go left or right for this point. I just have to go down. So we're going down 2. So instead of going down 2, I'm going to double that. I'm going to go down 4. So from my center of dilation, down 1, 2, 3, 4. There's my point. Okay, so now I'm going to connect all of my new points. Just like that. And if you notice, we have the same exact looking shape, like it hasn't changed. Like this shape still looks like this one. It's just bigger. In fact, it's twice as big. Okay, so that's an example of dilation with a scale factor of 2 around the origin, 0, 0 being our center of dilation. So we're going to do another example to kind of solidify this for us. So if you turn the page in your notes, this time we're going to follow different instructions. This time our scale factor is 1/2. So if your scale factor is a fraction, like 1/2, that means instead of multiplying by 2 or 3 and making things bigger, we're going to be dividing or multiplying by a fraction and making things smaller. So you can either multiply your instructions by 1/2, or you can divide them by 2. So this is a clue to us to divide by 2 on our instructions. And this time our center of dilation is also different. It's not the origin this time, it's the point 2, 0. So over 2, up 0. Okay, so here we go. We're going to do the same exact thing. We're going to make our instructions to each of the points. And then this time we're going to divide them by 2. So I'm going to go over to get to this point. I'm going to count my instructions. I have to go to the right. 1, 2, 3, 4, 5. And up. Or sorry, 6. Gosh, right 6. And up. 1, 2, 3, 4, 5, 6, 7. So instead of going to the right 6 and up 7, I'm going to divide my instructions by 2. So I'm going to go to the right 3 and up, well, this is an odd number and it doesn't divide evenly, but 7 divided by 2 is 3.5. So I'm going to go right 3, so 1, 2, 3, and up 1, 2, 3, and a half. So I'm just going to make it in between 3 and 4. Okay. So there's our first point. Next point, we have to go left 1, 2, and up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So instead of left 2 and up 10, I'm cutting each of these in half. So left 1 and up 5. So 1, 1, 2, 3, 4, 5. My next point, I have to go, it's over here, left 1, 2, 3, 4, 5, 6, 7, 8. And up 1, 2, 3, 4. So instead of left 8 and up 4, we're going to go left 4 and up 2. All right, and then for my last point, way down here, we have to go right 2 and down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So instead of right 2 and down 10, we're going to go right 1 and down 5. So right 1, down 1, 2, 3, 4, 5. All right, and then we're going to connect our dots. All right, so remember, you're always counting from your center of dilation point, but you never want to connect that as one of your dots. Also, if you get a shape that looks different than your original shape, then something might have gone wrong. So we want to make sure our shape always looks the same, just either smaller or larger than our original shape. All right, so that's your notes for dilations. Go ahead, your homework is going to be the rest of 20.3, so just finish the rest of the dilations problems. All right. See you guys later.